Called Blue Yonder. I am senior staff engineer in the GenAI area there. And Blue Yonder, for those of you who don't know, we are doing supply chain management, so everything related to goods and warehouse management and transportation management. And one of the projects I'm responsible there is a root cause analysis report. So what we are doing there, we are doing some data science, and in the end we transform everything into a nice report with the help of an LLM. So we are not throwing all the data in it and let the LLM analyze it. We have data science processes at hand, but the report generation and the text generation has been done with the LLM. So we are dealing with probabilistic outputs here and with systems which are non-deterministic. So as you might know, this is actually quite hard. Even the best companies in the world, like Google and Amazon, are very bad at it. If you look at the long tail, for example, you can still ask the Amazon recommendation to create a React component. Google is recommending to eat a stone once a day. So the traditional software engineering is quite simple, right? You have an input like 2 + 2, and you write a test to expect 4. But GenAI is exciting, because if you have 2 + 2, you might receive 4. Next run you receive 5. Next time you receive a poem about the number 4. You never know. So it's much harder to test large language models and probabilistic systems. And that brings us to Evals. You might have heard about Evals. Evals are the one and only solution to test large language models, and there are lots of off-the-shelf solutions out there. Like there are some dashboards, and you have numbers like helpfulness and truthfulness. But my manager, when I show him our report and I tell him, hey, our report has a score of helpfulness for the 2, yeah, he is probably looking at me and doesn't know what that actually means. And if I continue with, but we have a truthfulness of 4.5, he is even more confused. So I think we can all agree that those generic evals are creating this false sense of measurements. Those are not really good evals in place. So to sum up all the questions we have in mind, we need to find a good way to write better evals in the first place, okay? And if everything goes as planned, we might also use those tests to quantify our quality over time and track the improvements when we're working on it. That would also be very great. And we need to know what to work on next. That's also something lots of companies and teams don't know, actually. They have lots of ideas like, oh, let's try out this new RAG technology or this new framework, whatnot. But why and what problem you're exactly trying to solve with this is not quite clear. And last one, we also want to be sure when we are releasing a new model that everything is working quite fine. For example, Sarah Sachs, she is lead of the GenAI team at Notion, and she wrote that they released the newest Anthropic model back then within 24 hours after release. So I don't know, but please raise your hand if you're working with large language models in production. Okay, and please keep your hand up if you think you can answer all those questions. None, okay. Oh, 1, okay, great. For the rest of you, I hope that after this talk you feel much more confident and you drive back home and you start implementing much better evals. But let's see. So, spoiler, I will already tell you how to do it, and there's something called error analysis. This is nothing new. It's actually more than 50 years old already, and it was invented to test stochastical systems like OCR, for example. And it's quite an easy process. You create a data set, then you annotate those traces, and then you group those errors together, and in the end you iterate and refine more and more. That's the whole idea of error analysis. And to show you how easy it is and how much value it provides, we will do it with one of our examples of the report I showed you earlier. Okay, But before we can start, we need, of course, a mechanism to start collecting traces in the first place. Because if you are not able to monitor what your agent is doing, you have a problem. So there are lots of different solutions out there. A trace is the full end-to-end action your agent took, or your LLM, from input, how long it took, which model it used, how many tokens it consumed. So it tracks all the actions, and for a chatbot it might be easier. For an agent performing more steps, you have longer traces. But there are lots of solutions. I try to keep it as agnostic as possible. Length use, brain trust, you can choose whatever you want. But you need to start to collect traces in the first place. So now that you have some traces you can look at, you need to decide which traces you're annotating. And there might be many, many traces, and you need a mechanism to find out which one to start with. And with how many? And I can tell you, we need to keep our costs low. We cannot put someone at the desk and tell them, hey, please look at 1,000 traces. So you can start with 20 or even less. And you do this process until you reach a point of theoretical saturation. That means you don't find anything new. So it's quite easy. And which ones to choose? Well, you can use random sampling, or you use those generic evals like helpfulness as a baseline, and you select the first traces. Okay, here's an example from our reports. So as you can see in the top, we are talking about 100% of shipments are late, but the number of shipments is actually 0. So we need to put our product head on, and we simply annotate this trace from a customer perspective. And we would write down, this is a contradicting statement, for example. The next one, we are talking about severe inefficiencies and significant delays, but remember we don't have any late shipments, so we would also write this down, okay? And the important thing is, we are doing outcome-based evaluation. So we are looking at it from a customer perspective. So don't comment stuff like, oh, the model did not call the right tool at the right place here. So instead, from a customer, what would the customer have to say when he's reading the report, okay? So another example, average worker productivity stands at 14.52. Well, my teacher would have said 14 watt apples, so there's probably a unit missing. That would be nice to have. Also, we are talking about 25% of our workforce is low performers. If we would release this, I might receive a notification from HR. They want to discuss something with me. So better annotate this as well. And then there are more trickier ones, like low performers take 70% longer, blah, 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 due to packing congestions. This one is much trickier to spot, and that's why it's important to have some subject matter expert at hand to make those comments, because actually, since we have a congestion, the people take longer, and it's not the other way around. So this is a problem of inverse causality here, right? So if I would have shown this to an LLM, the LLM would have said, wow, it's a great report, I like it. That's important to know, so don't let an LLM write the comments for you, let an SME comment on your traces, okay? Now, the next thing is that we group all those comments together. And for example, we had several comments about the low performers, so we can group everything into judgmental language. And how you can group it? Well, here you can use an LLM again, throw everything into ChatGPT. Hey, ChatGPT, please group all those comments for me. Or you're using embeddings. And now I group this into judgmental language. Now judgmental language, that is a very good eval, right? Much better than helpfulness. And we had 168 comments, and we grouped them down into 19 different failure modes, okay? Okay, now that we know what we are going to test, in our case, let's test judgmental language, we can decide how we are going to test this. There are two different ways. One is verifiables. So, for example, you have a regex for units, for example, or you want to test how long the report is. You can do this via code. And you have non-verifiables like subjective things. And here you need LLM as a judge. You want to have as much as possible of verifiables. Why? Because they are repeatable, cheap, fast, much better. LLM as a judge, a little bit more expensive, slow. So try to keep as much as possible in this area, okay? But let's say you need to write an LLM as a judge. And the good thing is, now that you've written down all those comments, you can use those examples from your comments by putting them into the prompt. So you give some context, you're evaluating a root cause analysis report, and then you give some positive and negative examples. Okay? And in the end, you have a placeholder where you throw in the report, and then you have an LLM evaluating your report. Now, the thing is, if you then let the LLM decide how much judgmental language it has, it gets a little bit tricky. So, for example, if we have a so-called Likert scale, that's a scale from 1 to 5 or 1 to 7, it's very difficult to make a difference between 3.9 or 4.1. What's the difference anyway? So, the better option is to make it binary. Let the LLM as a judge return 1 in case of a failure mode and 0 in case there is no error. So you have a clear distinction between failure or not. And if you think about it, you have to make it a binary decision anyway, because even if you have a Likert scale, you need to decide what the cutoff rate is for you to say, okay, at this point it's too bad to put it into production, so you're making it a binary decision in the end anyway. So you can start it from scratch with binary returns right away. Okay, now that we know how we can write such an LLM as a judge, we need to make sure how we can trust him. That's also possible by bringing your SME back into play. So let's say we have decided, okay, judgmental language is an eval we want to have. We can give our SME 20 reports, let him label those 20 reports where he thinks that this contains judgmental language. And then we run our LLM as a judge, and we create something like a confusion matrix. And the important thing here is that we will focus on the true positives and the true negatives, because let's assume that the error is in the long tail, that we only have very rare errors. If we simply return every time 0 for we don't have an error, we might even get 99% accuracy, but in the end it's not really that good. So yeah, you can label those and compare it with a confusion matrix until you're satisfied. And the other question I get quite often is, can I use the same model for the evaluation as I'm using in my product? And the answer is yes, because usually the task is quite different than what you are actually doing on the other side. So if I let the LLM generate a report, that's quite a different task than grading it for judgmental language, right? But there are actually some models who identify, oh, this text looks like I have written this. I think I like it. So there are some, there might be some bias. There are some papers about this if you want to read more. But you can start with the most capable model first and then optimize for costs later. And another thing, there's when you reach 100% accuracy or pass rate as you want, that means you don't really know anymore what to work on next. So if you have a stochastic system like an LLM, you should never reach 100%. That simply means that your tests are not challenging enough. So if you really reach 100%, start your whole process from the beginning again, create new annotations, create new failure modes, and so on. Now, coming back to our report, I said we had 19 different failure modes. We also grouped them into 4 different main categories. For example, the judgmental language you can find in the bottom right here, as well as some generic titles, for example. And we could say both are related to presentation quality, right? So we can create this taxonomy, and this is quite cool because If we set up the LLM as a judge, as a continuous evaluation, and we grade every new report, we can simply create new data sets. We can, every time the LLM as a judge marked a report as judgmental language, put it in a custom data set only containing judgmental language. Or for the full presentation quality even, that might also be really nice. And there is a powerful technique in data science which is called counting. And if we apply this, we get this beautiful chart. So each color here is one top category. Blue, for example, is context clarity. Purple is presentation quality. And now we can see how often each error actually occurs. And if we then say how meaningful each error is for our product, we can actually decide what to work on next, what's most important for us to work on. And for example, when we are doing this for one model, we can repeat the whole process for multiple models. So this is an older chart, therefore the models are a bit older as well. Each color is a different model. Green, for example, is GPT-4.1 Nano. The red one is GPT-4o. And now we are running the same experiment for different models. And we can now compare, okay, GPT-4.1 Nano has only 96% error rate and GPT-4o 75. And now we have concrete numbers at hand to compare those things. And let's look at this chart. Those are the different top categories. And again, each color is a different model. And what can you see by looking at this chart? Well, the first thing you can see is that the errors are actually quite evenly distributed across the different models. And that tells you something, and it's that it's not a model problem we are having, it's a prompting problem. Because if it would be a model problem, one model would have more errors than the other, but it's actually quite evenly distributed. And now, together with the stats from our monitoring, where we track how long each request takes and how many tokens it consumes, and therefore how costly it is, we can actually create a report per model compared to our base model, and I can give this report to our manager and say, hey, for example, GPT-4.1 Nano reduced the context clarity by 6.2%, and it's running 37% faster even, and it's costing 96% less. That's something my manager can work with, right? Much better than, hey, we have helpfulness of 4.2. And based on those numbers, you can actually make decisions. And how you make those decisions is up to you. For example, let's compare it with a sink if you are washing dishes. You can start from the top and simply start with the most convenient one, or you take out the huge pot first and start with the biggest impact at first. That's totally up to you. And what you are ending up with is this beautiful data flywheel, right? So let's assume that you have a product in production and you're constantly monitoring this product. And also, you have set up all the LLM as a judge, so you have constant evaluations of your reports per each category from our 19 different failure modes. The product manager, or whoever is responsible for your decisions here, can now, based on those statistics, make decisions like, hey, we need to work on judgmental language, or the next release is focused on context clarity, for example, and is working on 5 different failure modes at once. Now he can take this task, plan it, and tell the engineer, the developer, hey, in our next release, we need to tackle judgmental language. Now the engineer has a concrete goal to work at, and how he's achieving this, that's completely up to the engineer in the end. He can try out a new RAG system, change the prompt, whatever. That's completely freedom how he's tackling this problem. And he also has metrics to test his own progress. And when he's satisfied, he can report back the new numbers to the product manager, and in the end, they can decide if it's good enough to release the new model or not. And you repeat this process over and over again, and by doing that, you can actually improve over time much better. So, coming back to our initial questions, how can we find good evals? That's the process I just described. You are doing error analysis by annotating your traces, then collecting those traces, grouping them together, and from those groups, by using those examples from your annotations, creating very good LLM as a judge prompts, and then by comparing it with the confusion matrix, you may get very good aligned with the SMEs. And then you have complete confidence that the LLM as a judge is exactly doing what you are trying to achieve. Now, how can we quantify the product quality? That we have seen in the bar chart. We can quantify and see the progress over time. And what's the most critical task to tackle on? Well, if you combine the actual bar charts and the errors with an impact level, or you give it a score, you can decide what's the most critical task to work on next. And the last one, how can we be sure to release a new model? Well, with this approach, whenever a new model comes out, you simply rerun it with all your LLM as a judge in place. You would get immediately this nice chart, how it compares to your current baseline, and you can give it to your manager, I don't know, 10 minutes after release, and 24 hours later, you can already run it in production. So there is actually some guy, Hamel Hussein. He is very famous for this whole process, and if you want to learn more about this, I highly recommend his course for this as well. It's quite costly, but it's worth it. Yeah, and from my side, that's actually it. If you think that was useful, feel free to get in touch with me. And also, we are hiring, so if you're interested in working some LLM and GenAI areas, then feel free to reach out, and happy to answer your questions.
Thank you, Martin. It was quite an interesting talk, and we have a dozen of questions at least.
Okay, I don't know if that's good. But
let's start with the first. How do you avoid the manual labeling hell when you iterate? So, for example, you change the prompt or the model or etc.
How I avoid what?
The manual labeling hell. So
you can't avoid this. So the manual labeling, the annotating, that's something someone has to do. As I said, you can't use an LLM for that. Someone with domain knowledge needs to do this. And yeah, the labeling, I mean, you can start by writing the LLM as a judge, and if you think it's good enough and you don't need to align it with an SME, that's also fine. But I would highly suggest that you align it by comparing the labels from your LLM as a judge with the labels from an SME.
Okay. The second one is, do you keep the LLM judge constant when evaluating different models, or do you change this too? Seems likely that evaluating a model with itself, even with a different context, can just reproduce value models.
No, you keep the prompt the same. That's crucial to make it a fair comparison. And if you would not do this, you would actually write a custom prompt just for the model. But the idea is that models come and go, and the prompts or the evals are here to stay. That's your ground truth and what you're trying to achieve. So don't customize prompts for different models just for testing. So for the testing, it has to be the same. When you have it in production and you see that the numbers are much better with a different prompt, that's of course totally fine. If that improves your overall quality, then.
Okay. The second one is, how do you evaluate text generation of a model quantitatively without LLM judges?
Yeah, that's the verifiable approach. So if you find things like, I don't know, units, for example, you can write a regex for that. You can have code to check how long the report is, and there are lots of different ideas. And I don't have more examples now, but that's the preferred way, actually. As I said, LLM as a judge is much more costly and takes much longer.
Okay, the next one would be a tricky one. How do we evaluate the benefit of a Gen AI generates?
That I can't answer. That has to be answered by product managers, how much that improves your numbers, like revenue from customers, etc., pp. So those are actually numbers your company needs to have in place to evaluate how much a new product or a new version of the product improves on business numbers.
Okay, just a moment. Oh my. You said the engineer focused on fixing one thing on each release. How do we ensure that doesn't make other factors worse?
Yeah, you run, of course, every eval you have in place. So what I meant was your engineer gets a specific task, like, I don't know, I could tell my colleague, hey, please work on judgmental language. And he can then go ahead, try different techniques to improve this. But before we release it, we will, of course, run all the evals again and see, okay, well, yeah, we fixed judgmental language, but all the other metrics are much worse now, then of course we would not release it. So that's why you have so many failure modes and evals in place. So every failure mode in the end becomes an LLM, an eval, and it's either evaluated through code, if it's verifiable, or through an LLM as a judge.
Okay, the next one, when do you run these tests if they are rather expensive?
Depends on how much you want to spend and how many you can afford. I mean, you need to definitely run this before you release something to be sure that you don't mess up. Preferably, you would also run this on a sampled set in production to measure online how you perform over time and also to discover user drift. That's a little bit tricky, but remember in the good old days, maybe some of you can remember when ChatGPT came out, what was the first thing everyone did? Hey ChatGPT, please write me a poem about, I don't know, please write me a poem about my job. And nowadays, nobody is actually writing poems with ChatGPT anymore. So there was a drift in user behavior. And if you have online evaluations also in hand, then you might see this in your evals and how the errors come back as well. And that's also then a good time to redo the whole process. But otherwise, it's a one-time process, and you don't have to do it that often. Yes, you need an SME in the beginning, and it might take some time, but it's totally worth it.
Good. The next one is an advanced one. What is the framework you are using to do the LLM as a judge?
In our case, we are simply using length views. That is also our monitoring, and you can set up LLM as a judge in there as well. But as I said, the whole idea of error analysis is framework agnostic. You can also write everything from scratch in your own infrastructure. That's totally up to you.
Okay. Yeah. When you use LLM as a judge, your return is binary, as you told. Mm-hmm. Do you have a threshold underneath, or 0 is really no error? I think like we have a gray area somewhere in between 0 and 1. Mm-hmm. So what can we probably do with it?
No, the prompt actually mentions that the judge is only allowed to create either 0 or 1. And we are using examples from our comments and tell the LLM as a judge, hey, if those things are included in the report, like low performers, that's definitely judgmental language, and can include other examples. And we can also use positive examples, what we would expect instead. But in the end, we want either 0 for everything is fine, or 1 if there was judgmental language in it. And of course, you can then average this score about your traces, like the last 100 reports, and have a continuous number, what the percentage is, and there you can have a threshold again, but it's easier to say that it's not allowed to, that we are having more than 10% of judgmental language in our reports than if you have a Likert scale that you define, okay, 2.3 is our cutoff rate, for example. That's much harder to do because, again, people default to the safe middle values anyway. It's like a Gauss curve. And if I asked someone here, they would, the average would be in the middle anyway. So it's much better to have binary decisions.
Okay, so I think we have a couple of more questions, though the time is over for this talk. Though I think if you have these questions, probably you can reach out to Martin directly.
Yeah.
So, and let's once again, thanks Martin for this great talk.
Thank you.